In this video, we're going to be going over practice problems for writing names and formulas. So this is our part 5 video inside of chemistry, chapter 2. So we're doing this video just as a quick summary of what we've done so far inside of chapter 2 and also inside of chapter 1 for learning about names and formulas inside of chemistry. So let's get started with our practice problems. So our practice question number 1 is, identify the binary compounds in the following list. So here we have a table with the questions in them. So what we need to do is identify which are the binary compounds. So just for a quick recap, binary compounds are basically where there's two different elements that combine together. So inside of binary compounds, there's also two different sections. One of them is a binary molecular compound and another is a binary ionic. So binary molecular means that there's two nonmetals, two different elements that combine. Binary ionic just means that there's a metal and a nonmetal combining. So in this case, binary compounds, we just need to look if there's two different elements. So for the first one, we have HCl, which is hydrochloric acid. So inside of hydrochloric acid, there's hydrogen plus chlorine. So that means it will be a binary compound because there's two different elements. For the next one, we have SO3, which is sulfur trioxide. So in this case, it's again a binary compound because it's sulfur plus oxygen. For the third one, we have MgCO3, which is magnesium carbonate. So this would not be a binary compound because there's three different compounds, three different elements that are combined together, and these three elements are magnesium, carbon, and oxygen. And finally, for the last one, we have sodium hydrogen carbonate, which is basically also not a binary compound because there's multiple different elements combined, which is 4 different ones. So if I pop out the answer here, we can see that the first one, HCl, is a binary compound. The second one is also a binary compound. The third one is not a binary compound. The fourth one is a binary compound. And finally, the last one is not a binary compound. So this is our first practice question. And let's move on to the next one now. So practice question number 2. Which types of elements combine to form binary ionic compounds? So as we said in the last slide, basically what binary compounds is two different elements combined together. So the answer for the solution should be a nonmetal with a metal. So binary ionic compounds are generally formed by the combination of metal elements with nonmetal elements. And the metals are typically found on the left side of the periodic table, and they lose electrons to become positively charged cations, while the nonmetals are on the right side of the periodic table, and those gain electrons to become negatively charged ions, anions. So if I pull up the periodic table here, we can see what we're talking about here. So we're saying that metals are found in the left side. So inside of this periodic table, most of this from the left side is all metals. So all of this here is considered as a metal. And then here on the right side of the staircase, you can say, these are all nonmetals. And in this case, usually these nonmetals are the ones that have a full outer shell, which means that they want to gain. So they're trying to get that full outer shell by gaining. And over here on the left, these metals want to give because they have 1 or 2 in the outer shell. So since you have 1 or 2, you're most likely want to give away those so you can have a full outer shell. So that's what we're saying here. The metals are found on the left and they usually lose electrons, and the ones on the right are nonmetals and they usually gain electrons. So now for practice question number 3, which type of elements combine to form molecular compounds? So in this case, if we talk about molecular compounds, that just means that there is a nonmetal combining with a nonmetal. So that means both of these are on the right side of the periodic table. So for the answer, molecular compounds are typically formed by the combination of nonmetal elements with other nonmetal elements. And these elements share electrons to form covalent bonds, resulting in molecules. So we talked more about this in chapter 1, so if you want to learn more about it, you can check that video out. But basically, these molecular compounds are formed by covalent bonds between nonmetals, which means that these nonmetals share electrons within each other. So since they share it, they become covalent bonds. So this is the answer to practice question number 3. So now for practice question number 4, examine the type of elements in each of the following substances, and then identify whether each name or formula represents an ionic or molecular substance. So in this table here, all we need to do is just identify if this is a molecular or ionic. So as we said before, ionic is a nonmetal with a metal, and then a molecular is a nonmetal and a nonmetal. So if we look at these examples here, for the first one we have sodium sulfide, which is basically sodium plus sulfur. So sodium, if we look on the periodic table again, I'll just bring it up. So if we look for sodium, sodium is right here. So sodium, since it's on the left side, that means it's a metal, and sulfur is on the right side, which means it's a non-metal. So since we have a non-metal and also metal, this means that sodium sulfide, this one would be ionic. So now if we look at the next one, we have PCl3. So P stands for phosphorus, and Cl we know is chlorine. So if we look here, so phosphorus is found right here and chlorine is found right here. So since they are both on the right side, this means that this is a non-metal and a non-metal. So these two non-metals combined make a molecular substance. And for the rest of these, I'm not going to explain them all because now you have an idea. So I'm just going to pull up the answers for the rest of them. So for the first one, sodium sulfide is an ionic substance because sodium is a metal and sulfur is a non-metal. So for PCl3, which is phosphorus trichloride, it is a molecular because both of them are non-metals. For nitrogen dioxide, this is also molecular because nitrogen and oxygen are both non-metals. For the third one, we have zinc oxide, which is ZNO inside of the formula. And basically this is an ionic substance because zinc is a metal and oxygen is a non-metal. So when those two combine, we get an ionic substance. And finally, for the last one, we have MgL2. And this is basically just magnesium iodine. So we have a magnesium, which is a metal, and we have iodine, which is a non-metal. So when you combine these two, we get an ionic substance. So this is the answer for practice question number 4. And now for question number 5. A binary ionic compound begins with the name of its cation, which is metallic, and ends with the name of its anion, which is non-metallic. And the anion name ends with the IDE suffix. And also the anion name ends with the IDE suffix. So what we need to do is we just need to fill out this table here, and we have to complete the information based on what we've given. So based on this prompt, we can understand that all anions, basically they are the nonmetals, and these end with the suffix of IDE inside of these binary ionic compounds. And for the other hand, so if we look at this table here, so the example that they gave us was fluorine. So if we look at the normal element of fluorine, so the element name is fluorine and the symbol is F. So if we look at our periodic table here, once again, we can see that fluorine is on the right side. So since it's on the right side, it means that fluorine is a nonmetal. And since fluorine is a nonmetal, then that means it's going to become an ion, which means that it's going to be at the back of a formula, and it's going to have -1. So with also an IDE suffix. So that's why we can see that fluorine becomes an anion with the name fluoride. Since it is an ion, we get the IDE suffix. And then it's going to have -1 because it gains an electron. So since fluorine has 7 in the outer shell, it wants to gain 1 electron. So once it gains that electron, then it's going to have a full shell. So that's why, since there's going to be 1 more electron than protons, that's why the symbol is F-. So now for the rest of them, we can try them. So for the second one, we have chloride. So the anion name is chloride. So we know that the element name is going to be chlorine. So if it's chlorine for the name, the symbol is Cl. And then if we look at our periodic table to see what the symbol will be, we can see that chlorine is right here, right beside the noble gases, which means it also has 1 in the outer shell. So since it's 17, that means it has 1 left in the outer shell, and it has 7 in there. So there's already 7 valence electrons in there, and it's looking to get 1 more. So we know that chlorine is going to have a -1. So it's going to be Cl -1. So same thing for the other ones. We can do the same process, but I'm not going to explain it all. I'm just going to pull out the table and we can see the answer from there. So as we said, for chlorine, it's going to be Cl, and the symbol is Cl-. So I'm going to skip bromine and I'm going to go to oxygen instead because bromine also has a -1. So for oxygen, the anion will be oxide, and the reason why we have -2, if we look over here, the reason why we have 2 minus is because oxygen has 8 total electrons. So since it has 8, that means the first shell will have 2 and the second one will have 6. So it's looking for 2 more. So since it's looking for 2 more, that means it's going to gain 2 electrons. So since it gains 2 electrons, it's going to have a charge of 2-. And the same thing for sulfur. And for nitrogen, that means it's looking for 3 more in the outer shell. So once it gains those 3, then it's going to become nitrogen 3-. So this is the answer for practice question number 5. So now for practice question number 6, find the total charge on the cations and the total charge on the anions. And then classify each formula as correct or incorrect. And then correct the incorrect formulas. And then also write the name of each compound. So I'm going to pull out the answer here so we can read along. So for the first one, what we basically have to do inside of all these questions, we have to just write the correct name and figure out if it's incorrect or if it's correct. If it's incorrect, then we need to write the correct name and also the correct formula. So the first one, we have lithium and oxygen. So once those two combine, we have lithium oxide, and we know this is incorrect. So if we look at the periodic table once more, so lithium, if we were to find it, lithium is right here. So lithium has 3 total electrons, so that means the outer shell has 1. So the outer shell has 1 valence electron. And if we look at oxygen, oxygen has, as we said in the last slide, oxygen has 2 that it needs. So that means oxygen has 6 valence electrons and it needs 2 more. So since lithium only has 1 to offer, this formula would be incorrect because lithium has a +1 charge and oxygen has a -2. So this means that to balance this out, if we have 2 different lithiums, so 2 different lithium atoms combined, then we're going to be able to balance it out. So the correct formula should be Li2, which means 2 lithiums, and 1 oxygen, which makes lithium oxide. So this would be the correct formula for this question. And the same process works for all the rest of these. I'm not going to explain all of them, but I'm going to explain this last one here, which is the second one. And for the rest of them, you can try them out for yourself and see if you get the correct answer. So for this one, we have MgO. So this is magnesium and oxygen. So let's see if this formula is correct. So we got to look for magnesium. So magnesium is right here. It has 12. So that means there is 2 extra valence electrons in the outer shell. And the second one was oxygen. So oxygen, we already know that it has 6 in the outer shell, so it needs 2 more. So in this case, it perfectly matches because magnesium has 2 to offer and oxygen has 2 to receive. So it perfectly matches, so that means this is correct. This formula is correct. So that summarizes practice question number 6. And that also summarizes everything for this video. So thank you so much for watching. Try to be useful, and we'll see you in our next chemistry video.